Hello and welcome to Nikolai's genetics lessons, and today's problem is people like other animals use lipids for most energy storage. This is because lipids store 6 times as much energy per kilogram as carbohydrates do. Only a small, though significant portion of our body's energy is stored as glycogen. Hypothetically, if person was to use glycogen exclusively, they would have to be much larger in order to store the same amount of energy. How much heavier would the person be? Assume that this individual is 60 kilograms and has 20% of body fat. And this is actually not a mathematical problem because it is very easy. Even second grader can solve this problem. I'm just going to use this problem in order to demonstrate two sources of energy and difference between them. So in this video I want to talk about lipids and sugars as source of energy. And let's take a look at this picture. So this is classical picture of lipid, and it consists of 3 parts glycerol. Here is carboxyl groups and fatty acids. And fatty acids can be of 3 different kinds. First would be saturated, and also here we see saturated, but here we see unsaturated, and we see double bond here between 2 adjacent carbons. So such a fatty acid we call monounsaturated fatty acid. And what significance it makes, as you see, fatty acid that is saturated would be more densely packed, and in the room temperature we would find that such lipids would be solid, and we call them fats. And monosaturated or polysaturated fatty acids in room temperature usually would be liquid because it wouldn't be so densely packed. Both fats and oils would be a great source of energy for all living organisms, including us humans. And now if you would take a look at this picture, you would find 2 types of fatty acids. It can be in its cis form, when 2 adjacent carbons would make a double bond and hydrogens would be on the same side. And trans fatty acid would be when 2 adjacent carbons that make double bond would have hydrogens on the different sides. Usually in the living organism we find fatty acids in its cis form, and trans form we can find when we use oils in order to make fats. So how fats are made using oils? It is easy. Liquid oils, which represent cis fatty acids, as you see, missing hydrogens here. So by blowing hydrogen gas through such fatty acids, we can create saturated fatty acid, which is going to be solid because would be more densely packed. But as byproduct we also can get fatty acid in its trans form, and these trans fatty acids would occur in much higher quantity if we compare with naturally occurring fatty acids in its cis form. So that's why on the labels of many products we show how much percent of the oil would be in its trans fatty acid form. So this is the first form of the energy storage in our organism, and this is long-term energy storage. And now let's compare with different energy source, which is glycogen. This is glycoprotein with protein core and branching sugars. All these sugars are glucose. One glycogen may have up to 120,000 such sugar residues. Now let's talk about molecular structure of the glycogen. So here you see that the same sugar would repeat. This is once again glucose, and these glucose residues can be connected by two types of connection making chains and branches. So here we see carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, and carbon number 6. And adjacent molecule also has the same numbers of carbon, number 1, 2, 3, 4, 5, and 6. So as you see, in a chain, two glucose molecules would be connected by alpha 1, 4 glycosidic bonding, and about every 3, 4 molecules, sugar molecules in a chain, we would also see branching. And once again, here we see carbon number 1, number 2, number 3, number 4, number 5, and 6. So here we have once again a branch bonding, which we call alpha 1, 6 glycosidic bonding. So this source of energy we can use immediately, so it can be found mostly in muscle cells and also in our liver. Now we can return to our problem. As I said, calculations is going to be very easy. We have a person who weighs 60 kilograms, and 20% of this would be body fat. So 10% of 60 would be 6 kilograms, and 20 would be 12 kilograms. So this person who weighs 60 kilograms, basically 48 kilograms plus 12 kilograms of fat. We also told that lipids store 6 times as much energy per kilogram as carbohydrates, so that means that we have to multiply 12 by 6, and we are going to get 72 kilograms of glycogen if we are going to substitute fat with glycogen. So our final answer would be 48 would be a body weight without fat. If we want to substitute all the fat with glycogen, we have to add 72 more kilograms of the glycogen, and body weight of such a person would double and would be 120 kilograms. So as you see, we need both glycogen for immediate access to energy, and also we need fat as long-term energy source. Otherwise our body weight would be too heavy for us to be competitive in this animal world. So as you see, we need both glycogen and fat, but we have to keep an eye on our body fat so it wouldn't exceed 20%. Otherwise we would be overweight and we will lose competition to other people and would be unattractive to opposite sex and will reduce our fitness. So this is all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day. Thumbs up if you like this video. Please write your comments, questions if you have any. Share this video with your classmates, and see you in the next video. Goodbye.